Alright, today we are looking at 6.2, which is perpendicular and angle bisectors, and this will relate to 5-1 in your old textbook. So the first thing that's important to know is the theorem. You always want to take a second and just make sure that you understand what you're saying. So this first part, the perpendicular bisector theorem, it says that if a point is on the perpendicular bisector of a segment, so first thing we know is that this line right here, xy, it is a perpendicular bisector, which means it is both perpendicular, so a 90-degree angle, and it bisects segment AB, so AY is the same thing as YB. If we know that we have this perpendicular bisector, then we know that it is the same distance from the endpoints, meaning that this line over here, AX, is going to be the same length as XB. Okay? The reverse is also true. If you have some line cutting through a segment and you know that the distance from this point X to A is the same as the distance from X to B, if you know that those two spots are congruent, then you know that this segment XY is a perpendicular bisector. So it works forward and backward. So how could that apply to some problems? So let's say that we have this big triangle ABC, and we have this segment BX cutting through. Now the only thing that we know about it is that it's perpendicular. We don't know if it bisects anything. We don't know anything, really, right now at least. So let's look as if we know this bit of information, that AB, so the distance from A to B, is the same as the distance from B to C, and they're both 5. So let's just fill in that information. And then it says that CX is equal to 2. So the distance from C to X right here is equal to 2. So let's analyze. We know that from B to A is the same as B to C. This would be the second, the converse of the perpendicular bisector theorem. Those two sides are congruent. That means that BX is not only perpendicular, but it's also a bisector. So what that means is it bisects AC. So if X to C is 2, A to X is 2 as well. So AX equals 2. In a totally different turn of events, let's erase this information that we filled out. Let's say that we knew something absolutely totally different for this triangle. So again, we have this triangle. There's a perpendicular here, but we don't know if it's a bisector. But you know what? Now we do. So BX is in fact a perpendicular bisector. Word bisector means that AX is congruent to XC. This symbol right here, that means perpendicular. It's shorthand. So BX is a perpendicular bisector. So it's 90 degrees and it cuts AC in half. So AX is equal to 4A and CX is equal to 2A plus 26. So we want to know what is the actual distance of CX. So this half over here is equal to this half over here. So what we can say is that 4A equals 2A plus 26. So the first thing we want to do is subtract 2A from both sides. Because remember, we want to solve and get our variables on one side of the equation. So we're left with 2A equals 26. And so if we divide by 2 on both sides, we find that A equals 13. Now that's just what A equals. Our question was, what does CX equal? So 2 times, instead of A, we say 13 plus 26. So 2 times 13 is 26 plus 26. So if we add those together, we would get 52. So what does CX equal? 52. So that's another application of perpendicular bisectors. Perpendicular bisectors of segments are kind of one category here, and another category would be angle bisectors. So we're dealing with an angle. Let me change colors here. So we're dealing with this angle APB. And so what we say is if we have a point on the bisector of an angle, so what we know is that this segment right here, PC, is an angle bisector. That means it's cutting this larger angle perfectly in half. So if there is a point on that bisector, then it is equidistant. That means that if this is an angle bisector, so we already know that this ray right here is right in the middle of angle APB, then this distance A to C is the same as C to B. So AC equals CB. The reverse is also true, the converse. If you have a ray in the middle of an angle, you don't know if it's exactly in the middle, you don't know if it's an angle bisector, but what you do know is that if you stand at C, it's the same distance to get to A as it is to get to B. If you know that that's the same distance, those perpendiculars are the same length, so if that distance is the same, that means that we do in fact have an angle bisector. So again, this works forward and backward. How that applies to our picture here. So let's say that ray BD bisects angle ABC. So what we know is that this red ray is an angle bisector, which means that this angle is congruent to this angle. That also tells us that the distance of the perpendicular from D to C, whatever that distance is going to be the same as the distance from D to A. So we know both of those bits of information. So this first part says that ABD, so this small angle here is 23 degrees. So the question is, what is the measure of ABC? Well, if ABD is 23, remember this is an angle bisector, so this one is also 23 degrees, which means that the whole angle ABC is going to be 23 plus 23, which is 46 degrees. We're also told that the distance from D to A is equal to 5. And remember, our theorem said if DA is 5, then that's congruent to DC, which is also 5. So what's DC? It's 5 as well. So let's erase some of this. Let's erase what we wrote here, because now we have a totally different scenario. All we know is that we have this red ray. We don't know if it's a bisector or anything just yet, but we know that the distance from D to A is the same as the distance from D to C. So these are congruent. And remember, if those distances are the same, then we automatically know that this is BD is an angle bisector and that these two small angles are congruent. So ABC, this whole angle, is 66 degrees. So the large angle ABC is 66 degrees. What is the measure of angle CBD? So what is half of that? Well, half of 66 is 33 degrees. And that's how you can apply angle bisectors and theorems there. The last thing we could do is we could be given 2 points. So point A is 2, -6, and point B is 4, 0. So it's going to be a segment. So just picture, if you will, an X and Y axis. You can always plot on graph paper. So we can go 2 over 2 and down 6. 1, 2, 3, 4, 5, 6. So that means A is going to be right about there. And B is over 4. Up or down 0. So there's A, there's B. Here's a segment. We want to figure out the equation of the perpendicular bisector. And we want to use point-slope form. Remember, point-slope form is y minus y1 equals m times x minus x1. What we need to find is a point and a slope. So what's the point and the slope that we want to find? Well, we want to find the perpendicular slope. And bisector, remember, that deals with midpoint. So those are the 2 bits of information that we need to find. The midpoint of AB, and we need to find the slope of the perpendicular to AB. So the first thing we're going to do is we're going to find the midpoint. Let's call it MP, midpoint. Remember, midpoint formula is where you add up the x values, so 2 plus 4, and you divide them by 2. You add up the y values, 6 plus 0, and you divide by 2. So remember, midpoint is a point, so you have to have x coordinate and a y coordinate. So if we simplify here, 2 plus 4 is 6, divided by 2 gives us 3. negative 6, erase that little curve right there. Negative 6 plus 0 is negative 6, divided by 2 is negative 3. So the midpoint is 3, negative 3, which makes sense. Over 3, down 3, right about here. So that's the midpoint. And that's the point that we're going to use. That's the x1 and the y1 that we're going to need to use in our point-slope formula. Now we need to find the slope. So the first thing we need to do is find the slope of AB. Then we need to find the perpendicular slope. So the first thing let's do is find the slope. Remember, that's when you subtract your y values, negative 6 minus 0, and divide by subtraction of the x values, 2 minus 4. So if we simplify this, that's negative 6 over negative 2, which is positive 3. Now that's the slope of AB. We want the slope of the perpendicular. So the perpendicular slope, that's what that shorthand means, perpendicular and the slope, is the opposite. So 3 is positive, so we want negative. Reciprocal or refliprocal, so it's 3 over 1. So the reciprocal is 1/3. So this is the point we want to use. And right here, negative 1/3 is the slope that we want to use. So to determine what our equation would be, we want to do y minus y1, so negative 3, equals the perpendicular slope, which is negative 1/3, times x minus the x-coordinate of the midpoint, which is 3. You may leave it in this format, although the only bit of simplification that I would like to see is minus a negative here. So y minus negative 3 should be y plus 3. But it is totally acceptable to leave this equation in this format. Let me know if you guys need any help.